Welcome. Today we're going to talk about lesson 2.2, where we're going to discuss basic derivative rules and rates of change. So in our last lesson, we really explored the definition of the derivative. What we're going to be doing moving forward is we're going to look at some ways to make finding the derivative a little easier than using that difference quotient we talked about in lesson 2.1. So the first thing we're going to talk about is actually a theorem. This is theorem 2.2, which is the constant rule. And really the constant rule, all it says is if we are finding the derivative of a constant function, it's just always going to be 0. What that really means is, say we have a function f of x, and it's equal to c, and c is just some number. Could be 4, could be 2. Doesn't really matter. Then the derivative f prime of x is going to equal 0 all the time. We're also going to look at another theorem before we look at any examples. Our next theorem, theorem 2.3, is going to be the power rule. And what we say for the power rule is if we let some value n represent a rational number, then the function, we're going to call the function f of x equal to x to the power of n is differentiable and if that's the case, the derivative is going to look like f prime of x is going to equal n times x to the power of n minus 1. Really all the power rule says is if we find the derivative, we take the power, put it in front of the variable, and then we reduce the power by 1. So now let's look at some examples. So our first example, we'll call this example 1. We're going to find y prime for the following functions. Really, we're just going to find the derivative. So the first one we're going to look at, we're going to have the function y equals 2. Well, based on the constant rule, y prime of a constant number, which 2 is a constant, the derivative of this function is just 0. And then we're done. Let's look at another one. I've got a couple more here. We'll look at b. We're going to say that y is equal to negative 1/2. Well, negative 1/2, that's still a constant. So that means the derivative in this case, y prime, is again going to equal 0. Let's look at one more where we utilize that constant rule. Some people might get tripped up a little bit here. We're going to have y equals pi. Now pi is not what most people would look at and think it is a constant, but there's no variable. Pi is a number. It's an irrational number, but it's still a number. So it's a constant function. So the derivative of pi is going to be 0. Y prime is going to be 0. Let's look at example 2, where we're going to actually practice using the power rule. So in example 2, we're going to find f prime of x when f of x is equal to x to the power of 5, and then we're going to find the slope of f of x at x equal -1, 0, and +1. So in our last lesson, we kind of talked about how the derivative looks at the slope of a tangent line, but that tangent line slope is the slope of the function at that point. So let's start by finding f prime. And from the power rule, what we're going to do is we're going to take that power that's on x, that 5, we're going to bring that out front. We're going to write a 5 there. We're going to have 5 times x. Now we're not going to rewrite the power as a 5. We have to, based off the power rule, reduce the power by 1. So the derivative of f of x is going to become 5x to the power of 4. So we've got one part of the problem we were asked to find. We found f prime, the derivative. Now to find the slope of the graph at x equals -1, 0, and 1, we're going to look for f prime of -1, f prime of 0, and f prime of 1. So all we're going to do is we're going to take the derivative function we found and replace x with these values. So f prime at -1 is going to be 5 times -1 to the power of 4. Well, -1 to the power of 4, that's 1. And 5 times 1 is 5. Let's also do that with 0. We're going to have 5 times 0 to the 4th. Well, 0 to the power of 4, that's 0. 5 times 0 is 0. So we found the slope at x equals 0. Let's do this also with the 1. We're going to go 5 times 1 to the power of 4. Well, 1 to the power of 4, that's 1. And 5 times 1 is 5. Well, guess what? We just found the last bit of the answer they asked us to do. We found the slope at 3 different x values. We've got time. Let's look at a couple more examples. So we've now explored a lot with derivatives. We can actually find the equation of a tangent line. So in example 3, we're going to do just that. We're going to find the equation of the tangent line to f of x equals x squared at x equals -2. So there's a few things we need to do. The first of which, step 1, is we're going to evaluate f of x at x equals -2. So we're going to find f of -2. To do that, we've learned this since Algebra 2. We're going to take f of x and we're just going to put -2 in for x. So f of -2 is going to equal -2 squared. And -2 times -2, that's +4. So we've got a point, -2, 4. This point is going to lie on our tangent line. So we're going to hold on to that, because now in step 2, we're going to find f prime of x. Well, we know f of x. We know f of x is x squared. So we can use the power rule to find the derivative. What we're going to do is we're going to take that power, which is a 2, and bring it out in front of our variable. And then we're going to reduce the original power, which was 2, by 1. So the derivative of x squared is just going to be 2x. And this derivative, we're going to use it to find the slope of our tangent line. So that actually leads us into step 3. We're going to evaluate f prime of x at x equals -2. What this is going to do is this is going to tell us the slope when our x value is -2. So f prime of -2, it's going to equal 2 times -2. Well, 2 times -2, that's -4. So that means our slope of our tangent line is -4. Now we know two things. We know a point that lies on this tangent line, and we know the slope. So here in step 4, we're going to use our ordered pair from step 1, and the slope from step 3, and we're going to plug them into the point slope form. So let's do that. Now, as a quick refresher, point slope form is written as y minus y1 equals m times x minus x1. And we actually know all the information we need to know. We have our m. M is just our slope. We have our y1 and x1. That's from our point we have in step 1. So let's just plug those values in to the equation. We're going to have y minus 4 equals -4 times x minus -2. So instead of writing a minus -2, I'm just going to write plus 2. Now, let's also put this into slope-intercept form, because that's really the generally accepted format. So to do that, we're going to first start by distributing this -4. So we're going to have y minus 4 is equal to -4x minus 8. We're almost done, because now what we'll do is we'll add 4 to both sides. So our equation is going to be y equals -4x minus 4. That means the equation of the line that is tangent to x squared when x is -2, that line is -4x minus 4. I think we have time for at least one more example in this video. So in example 4, all we're going to do is we're going to find the derivative. I've got two different functions to look at. The first function we're going to look at is f of x equals the cube root of x. Now, something I want us to first recall before we even find the derivative, we can rewrite any radical as a rational exponent, meaning an exponent that's a fraction. So f of x, instead of writing it as the cube root of x, what we can do is we can write it as x, and then the power, what's going to happen is it's going to be a fraction, where the numerator is whatever power is on the x originally, and the original power on x is a 1. So the numerator of our rational exponent is going to be a 1. The denominator is whatever the radical is. This radical is a cube root, so that means the denominator of our exponent is going to be a 3. So the cube root of x is the same as x to the 1/3. Now we can use the power rule when we're trying to find the derivative of this. What we're going to do to find f prime is we're going to take our power, which in this case is 1/3. We're going to write that in front of our x, and then we're going to subtract 1 from 1/3. Now 1 less than 1/3 is negative 2/3. And we're almost done. There is a little bit we can do to clean this up. If you recall from algebra, negative exponents, we can rewrite those as 1 over that thing that's raised to a negative power. So in this case we have 1/3, and we're multiplying that by 1 over x to the 2/3. And again, think back to algebra, multiplying these two fractions, we're going to have our derivative really just be 1 times 1 is 1 over 3x to the 2/3 power. We could go a little farther than that, but really we can stop here. If you wanted to go farther, this would really just be 1 over 3 cube roots of x squared. But I wouldn't worry about going that far. Let's look at one more before we close out this video. We're going to look at part B to this example. We're going to have y equals 1 over x squared. And using that same idea we used with a negative exponent, we can rewrite 1 over x squared as x to the negative 2. So when we're wanting to find the derivative, y prime, we're going to bring that negative 2 out in front of x, and then we're going to reduce the power, the negative 2, by 1, making it negative 3 with the power rule. Now we can still clean this up. Just like in the last problem, kind of undoing a negative power, we can rewrite this as negative 2 over x to the power of 3. And we've actually found the derivative of 1 over x squared. That's going to wrap up this video. Stay tuned for part 2 of lesson 2.2.